We continue with the chapter Geometric Distribution. This part concerns the mode of the geometric distribution. So if we have probability capital X is equal to R, we are interested to find which value of X will give the greatest probability. Or we can say we are looking for the most likely value of X. Or more precisely, we want to know on which trial we are most likely to obtain the first success. We can say that we have two features in common for all geometric distributions. The first one says that the mode of all geometric distribution is 1. That is, probability X is equal to 1 has the greatest probability for all geometric distribution. So we can say that we are most likely to obtain our first success on the first trial itself. And the second feature is that as the value of X increases, the probabilities, that is probability capital X is equal to R, decrease. So we are going to prove these two features. It is quite simple to show these two results by considering the formula to calculate probabilities for a geometric distribution. So if we have probability, so this is the proof. So if we have X follow geometric distribution with parameter P, that is P is a success, P success, so Q will be the failure, and we know that Q is 1 minus P. And we also can say that this value of Q should be less than 1 because it is a probability. So now we consider the probabilities. So first of all, we consider probability X is equal to 1. So this one, as we saw earlier in the previous lessons, this probability is P, that is first success is obtained on the first trial. Now if we consider probability X is equal to 2, this will become PQ. Next, probability X is equal to 3, this is PQ square, that is 2 failures followed by a success. So probability X is equal to 4, this will become PQ cube. Now, if we have probability X is equal to 1, it is P. To obtain probability X is equal to 2, we have to multiply P by Q. And we know that Q is a value less than 1. So when we take P, we multiply it by a value less than 1. This value of PQ will be less than P. So let's take a numerical example to illustrate this. If we have P is equal to 3/4, Q is equal to 1/4. So if we take PQ, we have to calculate 3/4 times 1/4, which is 3/16. So we can see that 3/16 is less than 3/4. So this one is less than 3/4. Therefore, we can say PQ is less than P. Now, if we compare PQ square with PQ, now if we have PQ square, this will be 3/16 times Q, which is 1/4, 3/64. So we see that 3/64 is less than 3/16. So we can say that PQ square is less than PQ. So this one is less than the previous term, which is PQ. Next, if we have PQ cube, again this will become 3/64 times 1/4, which is 3/256. So again 3/256 is less than 3/64. So we can say PQ cube is less than PQ square. So this will go on like this. So at the end we can say that P is greater than PQ is greater than PQ square is greater than PQ cube is greater than PQ power 4. It keeps on like that. So we have been able to prove these two features. The first one being P, the greatest probability. So it will become the mode. X is equal to 1 is the mode because P is the greatest probability. And the second feature, we can see that as the value of X increases, we can see that the probabilities are decreasing. So this is less than P, this one is less than PQ, this one is less than PQ square. It keeps on decreasing. So these are for the two important features for a geometric distribution. Now we'll illustrate some more examples. So the following table shows some probabilities for the distributions. We have two geometric distribution. So first of all, we have X follows a geometric distribution with parameter P 0.2, and the second one is X follows a geometric distribution with parameter P is equal to 0.7. So we have calculated the probabilities, that is the probabilities X is equal to 1 up to the probability X is equal to 5, and for both we can see that the highest probability occurs when X is equal to 1. So if we consider the first one, so 0.2 is greater than the rest of the probabilities. And also we can see the second feature where you can see the probabilities are decreasing. And the second one also, we can see that the highest probability is 0.7, and again the probabilities are decreasing. So we can clearly say that mode is equal to 1 for both distributions. So whenever we have to calculate the mode for a geometric distribution, we just have to write it as 1. No calculation is required. Next, we have the expectation of the geometric distribution. So if you recall, the notation for expectation is capital E, X capital. So, and it is also written as mu. So here we have another interesting result which says that if X follow a geometric distribution with parameter P, then mu, that is the expectation, is given as 1 over P. That is, we take the reciprocal of P. So this is the reciprocal of P, the reciprocal of the probability of success. So let's now use algebra to prove this result. So for X follow geometric distribution with parameter P, we have the following probability distribution. So we can write capital X here, or we write it as R. Probability capital X is equal to R. So here we have X taking values 1, 2, 3, 4, and so on. And we know that the probability, this one is P, this one PQ. Here we have PQ square, PQ cube. So this is our probability distribution table. So if you recall, to calculate the expectation, we use the formula summation of x times its corresponding probability. So here it will be mu. So we write mu, which is equal to, the first one is 1 times p, which is p. So we have 1 times p, which is p. Next, 2 times pq. The next one is 3 times pq square. Then we have 4 times pq cube, and so on. So we can write this as equation 1. Next, we multiply the equation, that is equation 1, by q. So next step, we multiply equation 1 throughout by q. So we will obtain mu times q. Here we have pq plus 2pq square plus 3pq cube plus 4pq power 4. This we write as equation 2. Next step, we are going to take equation 1 and then we subtract equation 2. By doing so, we will obtain mu minus mu q on the left hand side, and here we have p. So in the second equation, we have no term in p alone, so it's p minus 0. Next we have, so here we have 2pq minus pq. This becomes pq. Here we have 3pq square minus 2pq square. So we obtain pq square. These two can be subtracted. So 4pq cube minus 3pq cube, which gives us pq cube. And this will continue like that. Here we have pq power 4 and so on. So we can write it as mu common 1 minus q, which is equal to, so here we can see that we have an infinite sequence, and we can see that this one is a geometric progression with first term a is equal to p and the common ratio is q. We saw that for a geometric progression with first term p and common ratio q, we have the sum to infinity as 1. So when we add all these terms, we will have 1. So this is equal to 1. Therefore, 1 minus q, can write it as p is equal to 1. And then finally, we have mu as 1 over p. This is what we had to show. So we were able to show that mu, that is the expectation for a geometric distribution, is 1 over p. That is a reciprocal of the probability of success. Let's now take an example on mode and expectation. 1 in 4 boxes of Zingo breakfast cereal contains a free toy. Let the random variable x be the number of boxes that a child opens up to and including the one in which he finds his first toy. find the mode and the expectation of x. So here we can write the variable x as x follow a geometric distribution, and then we know that the probability of success is 1/4 because 1 in 4 boxes of Zingo breakfast contain a free toy, so it is 1 out of 4. So the probability of success is 1/4. So P is equal to 1/4, Q is equal to 3/4. So find the mode and the expectation of x. First part, the mode of x is 1. So we know the mode for all geometric distribution is 1. So, and then we have the expectation of x. So the expectation of x, we apply the formula. We know that mu is 1 over p. So here we have 1 divided by 1/4. That is a reciprocal of p, which is 4. So this is for the mode and expectation of x. And then part B, interpret the two values found in part A in the context of this question. So we have to interpret the mode and the expectation in this context. So the mode of x is 1. So here by the mode, we mean that the child is most likely to find his first toy in the first box he opens. This is for the mode. So this is for the mode, and then by the expectation being 4, this means that on average, the child will find his first toy in the 4th box that he opens. So for the mode, he is most likely to find his toy in the first box he opened, but on average, he will find it in the 4th box. So we can write, but on average, he will find his first toy in the 4th box that he opens. So that's all for this lesson. We will continue in the next one. Thank you.